Hello, welcome to Z Talk. In the series of Docker sessions, we have gone through Docker CLI and Docker Server basics. I believe we already had a solid understanding how does Docker work internally to build an image. In this session, I'd like to introduce more instruction commands by building a real project. And then we will move on to the next important concept, Docker Compose, to show you how do we deal with multiple local containers via Docker Compose. Okay, stay tuned. Let's get it started real quick. Here's the demo Node.js application that we're going to build looks like. We're going to build a really simple Node.js application, and all it does is to return a text message when we get access to it from our browser. So firstly, we're going to build the Node.js application, follow the normal procedure, and then we're going to containerize this application as a Docker image using the knowledge we've got in the previous sessions by creating Docker file. All right. And after the image is built, we're going to run the image as the container and connect it to the web application from a browser. Okay, let's start with the Node.js application. If you're not familiar with or interested in the Node.js part, feel free to jump to the next phase of creating a Docker file by clicking the timestamp in my description below. All right, cool. Okay, for building a simple web framework in Node.js, we're at least gonna need two configuration files, package.json, where we're gonna include all the dependencies for this application, and index.js, which is like the entry point of your Node.js application. Let me start with package.json. The first dependency I include is called Express, which is a fast, minimalist web framework for Node.js. And you can say I use star. Star means I can use any version of Express. Or you can put a specific version. It's based on your preference. And the second dependency is a script. I need to create a script to start this Node.js application, right? So that's pretty much the command node index.js. All right, so that's pretty much it. And now let's jump to the index.js. So inside of index.js, I'm gonna call or I'm gonna require the express that we just defined as a dependency in the previous package.json file. And then I'm gonna use these express library to create an application called demo_app. And then I'm gonna set up a route handler here. Let's say demo_app.get. I will pass in a string, and as a second argument, I will pass an arrow function with a request and response objects, and this function will return a string. Hello, welcome to ZTalk demo. Every time I hit the URL in the browser. And last but not least, I will have a application to listen a port, in this case, port 8080. And also I will pass in another arrow function as a second argument to print some message to the console, like the demo_app is listening on port 8080. That's pretty much it. Okay, the application is ready, so let's move on to the next step of containerization. Hopefully, you still remember the three important instruction commands we've gone through over the last session. Let's test it out. Here I list out in the Docker file. I list out the three steps for building your own image. So as you remember in the previous session, firstly, we're gonna specify a base image, right? So let's start. Let's still use the lean image Alpine like last session. So I'll do from Alpine. All right. And the next step will be install dependencies. So for this case, because it's a Node.js application, we're gonna need npm package manager, right? So let's do run npm install. And the last step, we're gonna define the default startup command, which is cmd, and we put some executable will be npm start. All right, that's it. So let's jump to the my terminal and see if it works. Inside of the folder where Docker file and the two Node.js configuration files were stored. All right, and let me issue docker build dot to build image. Hit enter. Oops, a error pops up. It says run npm install. So the executor failed running bin bash npm install. Okay, basically this error tells you that npm package we needed is not available in the Alpine base image. As you remember, we talked about Alpine in our previous session. Alpine is a extremely lean OS or base image. It contains very limited default programs. So in this case, npm package for Node.js is definitely not part of the default programs, which means we're gonna need some additional setup to get this working. So to solve this problem of npm not being part of the base image, we generally have two options. Number one, we can find a different base image that contains npm package. Alternatively, we can continue using Alpine image and run additional command to install npm on top of the Alpine base image. So for this demo, I will go with option one. Let me go to Docker Hub to find another base image with npm package installed. All right. Okay. I'm on Docker Hub. So all you need to do, you just need to type in Node in the search bar, and here you go. It's basically the Docker official image for Node. So if you scroll down further, and you will see there are a lot of different options of version or supported tags. So here, just give you an example, 16 hyphen, basically 16 means the version of Node. It's version 16, version 15, and after that it says is hyphen Alpine something. So now you might be curious why the tag's named like this. I mean, the purpose of Alpine being tied up to Node. Alpine is actually a term in the Docker world for an image that is as lean, as small, and compact as possible. So many popular repositories offer Alpine version of their images. So in this case of Alpine version of Node, basically it means that you're not gonna get any additional pre-installed programs. So it essentially has Node.js and pretty much nothing else. So you can actually take a look what specific programs are included in each of these supported tags by just click the tag, and it redirects you to GitHub, so you can see the Docker file to review what specific programs are installed for this specific version, right? And again, for this demo, because the simplicity of our demo application, we are totally okay with Alpine version, right? So let's just randomly pick a Alpine version, and let me go back to my Visual Studio Code. Okay, I randomly picked version 15 of Node.js Alpine version image as my base image. Since npm will be part of this image, I will just install the dependencies which I defined right here in the package.json. We need express to be installed, right? So go back to my Docker file. I just need to install express via npm. So run npm install express. All right. So let's save it and build a custom image out of this Docker file. Let's go issue docker build dot. Oops, we got an error when we run this npm install express command. This error called tracker ideal tree already exists. Okay, so basically, let me show you what I found regarding this error. So basically, this issue is happening due to changes in Node.js starting version 15. When no worker is specified, npm install is executed in the root directory of the container, which is resulting in this error. Okay, to fix this issue, I need to introduce you another important instruction command for building Docker custom image, which is worker. So it's pretty easy. So basically, worker defines the default location inside of the container where our customization files gonna be installed. All right. So let me jump to my Visual Studio Code, and all I need to do is before run this run instruction, we need to add another instruction code worker, and I will use user app as the default work dir. All right. So if these location does not exist out of box, when we build the image, it's gonna automatically create it. All right. So let's save it and go back to my terminal, run the command, the build command again, docker build dot. All right, so this time we got an image. Let me issue docker images, and here we go. This is the image we just created. All right, so we got the image. Now let's create a container out of this image by issuing docker run and copy the ID of this image. Hit enter. All right, so it pops up some notice and error. So the notice says there is a new version of npm available. So we can run this command to upgrade our npm to the latest version. And the error here says missing script start. Okay. To help you understand why did we receive this specific error, so let me jump to my note. I wanted to, I'll try to explain what's what's going on behind the scene. On the left side, we got our image that we just grabbed from Docker Hub. These custom image contains Node.js, npm package, all of those, all right? And on our right side, that's what we're gonna do. We're gonna create a container out of this custom image, right? And as you may remember, when we create a container, there will be a dedicated or isolated pieces of resources like CPU, RAM, network, and hardware being allocated to the container. For these case specifically, the file system snapshots inside of this image will be copied and loaded to the container, the hard drive segment part here. And here was actually the issue came from. So our custom config files like package.json and index.json were not contained in these image that we download from GitHub, Docker Hub. That's why we got that error saying the script were not found. This apparently because this is a custom image we got from Docker Hub, and it definitely not contain our configuration, right? So remember, the container was only connected to our own a small piece of hardware. It did not actually connect it to the rest of hardware in our machine, but our custom files like package.json, index.json were actually stored somewhere in the rest of hard drive, and there's no connection between here and here. So to fix this issue, what we need to do, we need to copy these or custom files from here to inside of the container. All right. So to be able to do that, I need to introduce you another important instruction command called copy. So let me jump back my slide. Here we go. This is the syntax of copy instruction. So the first / is the path to the folders to copy from our machine, right? It's relative to the build context. The second / is the path to copy stuff to inside of the container. All right. So for our case, let me jump back to my terminal, and or the package.json and index.js were actually stored in the same folder of Docker file. So back to Visual Studio Code, all I need to do, I just need to add a new line copy, and the first one will be dot because it's in the same directory of Docker file, and the second one is the location inside the container. I'm still going to use a dot because you see here in the previously already defined the default work dir is user app, and basically these dots gonna means we're gonna copy the whatever files to this location. Otherwise, if you have other place you want to store those files, you just need to put in the location. All right. So let me save it and build another image. All right. Let me jump to the Visual Studio Code. Let me jump to my terminal, and all I need to do, I need to rebuild the image by issuing oh, by the way, we had or this is our previous image we just created, right? So but you can see it just contains the image ID with this weird string. It's really hard to remember or identify what's this image for, right? We can actually assign a tag or to create like more human readable name for that image, for our custom image. So we can quickly figure out what that image for, right? So let's do that. It's by adding a tag argument. basically let me issue docker build, and we need to add a -t argument. And for naming convention of our custom image, the first part will be my account name of Docker Hub, right? So my account name is like this, and slash the second part will be the name of this image. So our image is for demo_app, and colon will give the version of our image. I'll call it latest. All right, so hit enter. Oh, sorry, I forgot the dot. All right, so now if I issue Docker images and Docker images, and you can see this was the new image we just created, and we got a tag, so it's more human readable, right? And let's create a container out of these new image and see if it works. Let me issue docker run, and we can just use these tag to create the container. Hit enter. Cool. It works. So you see the demo app is listening on port 8080. All right, let's as per our design. So what we're expecting, when we get access from our browser, we should expect when we hit the request, we will see a return message called "Hello, welcome to ZTalk demo." All right, let's verify if it works. Let me go to my browser, and I'll just issue local host and 8080. Hit enter. Whoops, it returns HTTP error 404 not found. Okay, let me explain why we receive this error instead of the expected message. Because we need to I need to introduce you another important concept about port mapping. All right. Okay, our application is running inside of the container that we just created, right? So the port 8080, you see inside of the index.js, the port 8080 that is listening, it's actually inside of the container. But when we test it out, we generated our traffic from our browser, which is not inside of the container. That's why we received that 404 error, because we did not define how do we route the traffic from our machine, from our browser to the container. Basically, to fix that, we need to map the port out, to map the port of our browser or machine to the container. So how do we do that? So it's pretty easy. Let me jump back to my terminal and cancel it out. So when we create the Docker container out of this image, we need to add a mapping. So Docker images and Docker run, and we need to include a argument called -p. Basically is for port mapping. So we're gonna use 9000 colon 8080 and the name of the image. So basically the first port is the port for the machine, right? The second port 8080 is the port inside of the container. So this way we're gonna route when we hit port 9000 from our machine or from our browser, it's gonna map that port to port 8080 inside of the container, right? So let's hit enter. All right, this time when we hit localhost, we're gonna hit port 9000, which we defined right here. We're gonna hit 9000 and you're gonna route these traffic to port 8080 inside of the container. Let's hit enter. Here we go. It says, hello, welcome to ZTalk demo. All right. That's pretty much I want to share. So basically from these projects, I think you will get more and more deep understanding how we're going to build our custom images, right? Okay, now let's wrap it up and jump to the next part of the session. Let me talk about Docker Compose. To get you better understand the use case of Docker Compose, let's continue use the Node.js project we just built out. We're going to extend the functionality of this demo app a little bit further. Instead of just returning a welcome message after I hit the 8080 port, right? I want to add a counter to record the number of visits of this application. For doing that, I will be adding Redis into the picture, which is an in-memory database. Now in my slide, we have two options regarding how are we gonna design this application architecture, right? So if you see in the top part, so option one, we can package or demo app Node.js application and Redis into one single container. This design should work just fine if we just have one container for our testing purpose, but consider a scenario where we project our application to have huge traffic. So to be able to handle that level of traffic, we're gonna have to scale out to have more instances to balance the traffic load, right? However, if that's the case, we're gonna run into some synchronization issue on Redis side based on this architecture, because each of container has a Redis index in it to count the number of visits to that specific instance. But there is no way to sum the number of visits up across instances to display the total number of visits to this application. So here comes to solve that issue. Here comes the alternative option. We can actually break Node.js app and Redis DB off into separate images. So when we need to scale out our application or Node.js application, we only add more Node.js app containers to handle the loads, and we only have one Redis container in the backend to count the total number of visits from all Node.js app containers. That way, we will not run into we don't have to deal with the database synchronization, right? So, but by doing this, we fix the DB issue. But there's another issue comes in. As you know, each container owns a little piece of system resources, and they are isolated between each other. So how do we hook multiple containers up so that we can talk to each other? Here is where Docker Compose goes on to the stage. All right, Docker Compose, it's a separate CLI tool that gets installed along with Docker. Basically, it's used to start up multiple Docker containers at the same time and automatically connect them together. Okay, to make use of Docker Compose, we're essentially going to take the same commands that we used before, like Docker build and Docker run. However, we're going to encode these commands into a specific file called docker-compose.yaml. And then this configuration file will be sent to Docker Compose CLI, and the CLI will be parsing the configuration inside of these docker-compose.yaml and create containers based on instruction inside of this definition. All right. Okay, now we're ready to jump back to the demo. I will be modifying the existing config file to include the new stuff for our enrichment. Again, if you're not familiar with or interested in Node.js parts, feel free to jump to the next section by clicking the timestamp in my description. All right, and one more thing, thumb up my video and subscribe my channel. Cool. Let me start with package.json. The only update I did inside of this file was that I added another dependency of Redis. And I used version 3.1.2, which is the latest. All right. And jump to index.js, same thing. I just include the dependency of Redis and create a client out of Redis. And set the variable visits, and the initial value of these variable will be 0, and it's gonna be the counter to count how many visits we got for our application. All right, and move down to line 8. So every time we hit the root URL, we're still gonna receive that message, hello, welcome to ZTalk demo. But besides of that, we're gonna also load these variable, the visits from Redis, and show the current number of visits to our application. And after that, we're gonna count it up by 1 because we hit the URL and we got one more visit, right? That's pretty much it. Pretty simple, right? Last but not least, let's jump to Docker file. So this Docker file is pretty much identical like what I did in our previous image, right? The only difference you may notice, I kind of broke the copy command into 2 pieces, and it's a kind of trick. I will explain you shortly why did I do it this way. Basically, it's for improving the efficiency of our Docker file. I'll explain shortly. All right. Okay, let's create our first Docker Compose file. All right, so here we go. This is the basic structure of a docker-compose.yaml file. As you can see in the first line, we need to specify the version of Docker Compose that we're going to use. In this case, is v3, right? And then we move to the services section. Each service represents a type of container. As per our design, we're gonna need 2 types of container. The first container is gonna host the Redis DB as our backend. And the second container is gonna host our demo Node.js application, right? That's why I add 2 services inside of the services section. And let's start with the first service. As you can see, we need to provide or we need to define a name for that service as the first step here. Basically, you can name whatever you want. And like for Redis, I just call it Redis-server. And for Redis, I just gonna grab the official Redis image from Docker Hub. So for doing that in Docker Compose, I just need to add the image key and put the name of that image as the value right here. So let me jump to Docker Hub and search for Redis, and here we go. The Docker official image, the name of this image is Redis. That's why that's what I put right here as value. And then let's move to the next service. That's gonna be the one for our demo Node.js application, right? Because we develop these application ourselves, we're gonna firstly build a image out of it. And as you remember, when we did it in Docker CLI, we just issued Docker build, right? it's kind of same thing in Docker Compose. What we need to do, we just need to use these build key and put dot as the value of this key value pair. So basically, dot means defines the build context. So let me jump to my terminal, and here this is the folder where I stored the docker-compose along with other configuration files. Basically, this dot means when you build the image, you need to refer all the configuration files inside of these folder. And once the image is ready, remember in the Docker CLI, we need to create a container out of that, right? So when we create a container, we need to do some port mapping to map the port on our machine to the port inside of the container, so that when we hit the traffic from our browser, it could route it to it could route the traffic to the port inside of the container, right? So in Docker Compose, we just need to use these ports key. Note here, so when we define our port mapping, we use a hyphen. Basically, it means it's a list. So we can map multiple ports as needed. All right, that's pretty much it. All right, we got the docker-compose.yaml file ready. As you recall, to my slide previously, I mentioned one of the most important features or use cases of Docker Compose is that it's able to start multiple containers up, and it also handles the network to connect all those containers together out of box, right? So based on that feature, let's move to index.js. As you can see inside this file, line 5, I create a client out of Redis, but I did not provide the information how are we gonna communicate with this client yet, right? So normally all I need to do is to add a host and port so that it knows that's where we're gonna communicate with this client, right? Because Docker Compose takes care of the network. So for host, we can directly refer host as the name of the service that we define in the Docker Compose. So let's jump back to Docker Compose, and we name Redis service as Redis-server, right? So let's copy the name of this service and jump back to index. Here we go. So for host, we just need to refer the name of that service, which we define in the Docker Compose.yaml, and the port, we're just gonna use the default port of Redis, which is 6379. All right, that's it. Now let's save it, and we are ready to run the Docker Compose commands to download or create the image and build container out of them. All right, jump to my terminal, and the command is pretty easy. Just issue docker-compose up, hit enter. Because it's the first time, it's gonna take a little bit longer to parse and download the container from Docker Hub or create a container. Download the image from Docker Hub and create an image if it's needed. All right. Cool. So it's already done, and you see the container is already up and running. Let's test it out by hit that hit port 9000, localhost port 9000. Okay, we got that message of hello, welcome to ZTalk demo, right? But somehow we did not see the enrichment. So we should have seen the number of visits of our application after this welcome message. Let's move back to the terminal and see what's going on inside the log. Oh, it's pop up in the error. It says cannot set headers after they are sent to the client. Okay, seems we need some troubleshooting. Why do we get these error, right? Okay. All right, these highlight error message cannot set headers after they are sent to the client. Basically, it means you're actually already in the body or finished states, but somehow some other function tried to set a header again. That's these error message all about. So that's definitely something wrong inside of the index.js script. So let's take a look one more time about our script. So, and here was where the issue came from. As you can see, our original application, every time we hit the root URL in line 12, the response that's sent is gonna return a welcome message, hello, welcome to ZTalk demo. All right, so that's basically what it means. It's already done by after the response that's sent. So we're already in the body or finished states after line 12, but because we added an enrichment, we added a new client function. We beside this welcome message, we still want to load the visits variable from Redis to show the current number of visits of our application, right? And as you can see in line 14, it used that response that sent again. That's where the error message pop-ups. Basically, these function try to set a header again, right? All right, to fix that is pretty easy. All we need to do, we just have to use response that sent once, right? So what we can do, we can just copy the message in the first response that's sent, and then take it out and move the message to here. All right, cool. Let's save it. This time we should not receive that error anymore. So because we changed or we modified our script, we have to rebuild our image and recreate container out of the new image. Right? So let's do that. So let's jump back to the terminal, and to recreate a new image, all we need to do, we just need to issue docker-compose up and add that argument --build. This time it will be faster because, as you can see here, the number 2, number 3, and number 4 steps were cached, and there was no change, right? So it should be really fast. Like the container is already up and running. So let's try it again. This time we should be able to see the number of visits. So let's refresh, and here we go. Along with the welcome message, we also see the number of visits. So if we refresh to generate more traffic, the number of visits will count up and change the value from 0 to 1, right? Let's hit refresh, and you can see it's changed to 1, and do that again, it's gonna be 2. Do that again, it's gonna be 3. All right, these counter works exactly what we wanted, right? Cool. That's pretty much what I want to show you about how do we use Docker Compose to create multiple containers and communicate with them automatically. This is one of the use case of Docker Compose. All right. So the last part of of this session, like I promised, let me go back to the Docker file. As I promised, I want to explain to you a little bit about this trick. Why did I say this way? By break the copy of to two copy commands will improve the performance of this Docker file. All right. All right, back to the original Docker file that we created a while back ago. As we already knew the way Docker build works, right? When an image is being built, it follows the sequence that we define inside of Docker file. And every step inside of the Docker file, once it's being executed, is gonna be cached in memory, so that next time when we need to rebuild the image out of any reason, it's gonna, for each step, it's gonna compare with the cache first. If there was no changes being detected for each step, it's gonna use cache to avoid from redoing the whole thing again. However, if something was changed, for example, at step 2, we changed the working directory to somewhere else, if that's the case, starting from step 2 down to the last step, the cache will not work anymore. What's going to happen is going to follow the instruction and redo the whole thing starting from the step where the change was detected. All right. To prove my points, let's jump to terminal, and let me clear the cache first by issuing docker system prune -a. Hit it. Yes. All right. You can see all build cache objects were removed, and let's issue docker build dot, hit enter. Because all the cache was removed, is gonna be the first time to parse and execute this Docker file, and you can see each step how long did it take to perform the instruction, especially at step 4. Run npm install, you can see it took 3.1 seconds. All right, next step, without changing anything inside of the Docker file, let's issue docker build one more time, and let's compare. All right, you can see how fast it was compared with the first time. Why? Because you can see at step 2, 3, 4, it did not redo the work. It used cache instead. And you can see, because it used cache, it did not take any time, 0 seconds, to perform those steps. All right? Okay, now let's back to my Visual Studio Code. Change the worker from user application to, for example, user app. Let's create a new folder and save it. And this time, issue docker build again. Let's see what happened. All right, this time, see here, starting from step 2 down to 4 of the step, and it did not use cache anymore. It's actually redo the work. And you can see step 4, it took 3 seconds. Comparing with the previous test, it took 0 seconds because of cache. All right, that's the difference. And I believe now you already know why I have to break copy into 2 before and after run npm install commands, because actually the only file required for run npm install was package.json instead of all. Because inside the package.json we define all the dependencies that is required for this project, right? That's basically what npm install needs. Use that dependencies to install whatever dependencies required. It actually doesn't care about index.js. All right, now consider a scenario. What if we change something inside of index.js? For example, we modify the message in the response that's sent by adding a "how are you doing?" So to make this change be effective, what we need to do, we need to rebuild the image and recreate a container out of the new image, right? So back to Docker file. If we're doing the old way, like copy dot before run npm, basically copy every single file to the container before npm install. So from step 3, copy dot, due to the change being detected in index.js, starting from step 3 down to step 4, the cache will not work anymore. You're gonna follow the instruction and redo the work. Now you can get the benefits why I did this way. Dot package.json dot, and after the npm install I do another copy dot. So if we define the Docker file this way, so it will be, the performance will be improved a lot. Remember, this step was the step that took most of the time, and if we're doing this way, we're still gonna use cache. We don't have to redo this step due to that change in the index.js, because this index.js was copied after the npm install step, right? So that's the benefit we got out of this new definition. Basically, we minimize the cache busting and rebuilds. All right, that's pretty much what I want to share in this whole session. I know it's quite a lot, so it takes time to absorb. All right, so take your time. Feel free to review this video multiple times. All right, let's call it a day, and see you next time. Alright, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.